Hello .NET developers. Today I'm going to show you how to build a multi-tenant web application. We're going to use ASP.NET 7 and Entity Framework Core. First we'll set up our web API application as just a regular CRUD application with one entity called products, and then after that we'll transform the solution to be multi-tenant. So it's going to be a simple architecture. It's going to be a single database multi-tenant architecture. We're not going to be using any third-party plugins. We're going to do all of this with just middleware and some query filters. By the way, there's a written version of this tutorial. It's on my blog at aspnano.com. Alright, so the first part of this video, like I said, we'll set it up as a CRUD application. I'm going to go kind of quickly through that because that's not the focus of this tutorial. But once we have that, we'll start adding in the elements that makes this multi-tenant behavior work. So I'm going to go create a new project in Visual Studio 2022, and I'm going to select ASP.NET Core Web API. So give it a name and choose the framework. We won't have any authentication. We're not going to use ASP identity. We won't have any login or anything like that. Again, if you're interested in that type of thing, definitely check out the Boilerplate. The link's in the description. The Boilerplate has all of that. Okay, so here's our application. I'm just going to delete this weather forecast. So let's start by installing the necessary Entity Framework NuGet packages. There's 3 that we need to install. The first one is Entity Framework Core. The next one is Entity Framework SQL Server, because we're going to use SQL Server as our database. And lastly, Entity Framework Core Tools. This will help us scaffold our migrations. Okay, so next let's create a folder called Models. And we'll add a class called ApplicationDbContext. Make sure your ApplicationDbContext derives from DbContext, which is an Entity Framework Core class. And next, let's create a new entity called Product. Our product entity will just have an integer ID, a name, and a description. Next, let's add that entity as a DB set to our ApplicationDbContext. Let's create a new folder called Services. We'll create a new class called Product Service and an interface called iProductService. Let's also create a folder called DTOs. And let's create a class called CreateProductRequest. This will just be a simple DTO class for when we create products. Okay, next you'll want to create the product service methods like this. First you'll create a constructor with the ApplicationDbContext. We'll have one method for getAllProducts that returns a list, a createProduct method that takes the product request and saves the changes to the database, and a deleteProduct method that deletes the product from the database. And at the top here you see that the service implements the iProductService interface. So next let's add this service to our service container. I'm going to get rid of Swagger. And just here, this line, builder services, add transient, iProductService, the interface, and the product service, the service. Next, let's create a controller that can use this service. We're going to create an API controller, empty, and let's call it the products controller. The products controller will use our product service like so, using dependency injection, and we'll create a get method, a post method, and a delete method to use each of the methods that we have in our service. With that out of the way, we should be able to do CRUD operations using REST commands and interact with our application once it's running with Postman. One more thing we need to do is we need to go to appsettings.json and we need to add our default connection string. So add that like so, and you can change this database value to be whatever you want the name of the database to be. In mine, I'm naming it MTADB, Multi-Tenant App Database. Next, go to the program.cs and add this line, builder.services, add DbContext, ApplicationDbContext. We're going to pass some options to use SQL Server and tell it to use the default connection. At this point, we've done everything that we need to create a functional CRUD application web API, and no doubt you've seen this 1,000 times before. Nothing we've done up to this point is new. But now that we're all on the same page, we can start to make this multi-tenant. So let's start by creating a new entity called Tenant. Now, most tutorials, there's not that many tutorials on multi-tenancy, but almost all of the ones that I've seen, they don't actually show you how to manage the tenant keys within a database. All of the examples are super simple and just show you how to do it with a JSON list or something like that. But that's not really useful because you're going to store tenants in a database, right? Our tenant entity is going to have two columns. It's going to have an ID and a name. The ID is going to be a string value, not an integer. And why is that? Well, it's because it'll make our life easier, and also because tenants are typically identified by strings. If you think about a SaaS application where every tenant has their own subdomain, that subdomain is usually the ID of the tenant. So it makes sense to save our tenant keys as strings. Now, since we're doing that, we need to tell Entity Framework that this is what we want to use for our ID. So that's why we have this first annotation here. The second annotation is saying that we will generate our own keys. We don't want the database to do it. So you'll need to add both of these data annotations, and you'll have these using statements at the top. In this tutorial, we're just going to manually create tenants in our database directly. We're not going to set up any kind of controller or service for managing that. Now, in our product entity, we're going to need to add another column, which is the tenant ID. But before we do that, let's do something else. Let's create a contract interface. The contract interface we're going to create is called IMustHaveTenant. And this interface is going to have one property, a string tenant ID. Now let's implement this interface on product and add the field. So this interface will help us group which entities should be tenant isolated. Maybe not all of them should be tenant isolated. Next, let's add this dbSetTenants in our ApplicationDbContext. And now we can create our first migration. So add migration initial. And this looks good, so let's go ahead and apply the migration with the update database command. Now if we open up our Database Explorer, we'll see that there's a new database created, MTADB, with two tables, products and tenants. And the products table has name, description, tenant ID, just like we wanted. And the tenants, let's go ahead and create a few. Now, the way that we're going to resolve our tenants is by reading a request header. So for every single request, we're going to be looking for a header that has a key value of tenant, and we're going to read that value. On every request that we send up, we can change this and it will signify that a different tenant is making that request. Now, in the real world, you would only want to do this on unauthenticated requests, like when someone is logging into the application. But for authenticated requests, you wouldn't want to do that because these can be easily changed. In authenticated requests, you would want to read a value or a claim from a token or a cookie if you're using Pages. Now, that's outside of the scope of this tutorial, but if that's something that you're interested in, look into the Nano boilerplate because that's got all that already set up. And it can be quite tedious to try and work through all that. So again, the link's in the description if you're looking to fast track a new web application or a SaaS project. So on every request, the thing that we want to do before anything else happens is read that tenant key in the header. The perfect tool for the job in that case is Middleware, because Middleware runs before any controller is hit or anything else happens in the application. So let's create some middleware. Let's start by creating a new folder called Middleware. And we'll add a new class in middleware called Tenant Resolver. So I've set up this middleware just like you would set up any middleware, with the request delegate in the constructor and with this async method here. What we're doing is we're reading from the HTTPContext object. The HTTPContext object is an important object. It includes all of the information about the incoming requests. And the information we want to get there is the headers. So here what we're doing is we're looking for a header with a key value called tenant. What we want to do is we want to hold on to that ID and make it available for the rest of the request lifecycle. To do that, what we'll do is we'll create a scoped service. So let's do that. Let's go in the services. Let's create a new interface and a new class. We'll create a new interface called currentTenantService. This service will have one property, string property for the tenant ID, and a method for setting that ID. Now let's create the service called currentTenantService. And the service will look like this. We'll have a string where we save the tenant ID, and we'll have the method where we set it. In the method setTenant, we'll need to check the database to see that this tenant exists. We also might want to load subscription information or to check to see if this tenant is active. Now the important thing about this service is that we register it as a scoped service. And the reason for that is because we don't want this value to change at all throughout the entire lifetime of the request. In the program.cs, we'll add this here as a scoped service. Now let's remember to add our middleware here with the use middleware directive and pass in tenant resolver. Now back in the tenant resolver, we'll want to make use of this service. With middleware, we inject services like this. We don't actually inject them into the constructor. It's just convention for middleware. Now if we find a header called tenant and we have a key, then we'll use our currentTenantService method setTenant and populate that value. Now what we can do in ApplicationDbContext is we can use this service and we can read the tenant ID anytime that the database context is accessed. So now we'll add a new override method in the ApplicationDbContext, public override save changes. And this will run anytime that we save any changes to our database. So anytime that we save changes, the current tenant ID that we get from our service will be saved in the tenant ID column of that entity. Now that's one piece of the puzzle. The other piece of the puzzle is that we want to filter anytime that we read from the database. So to do that, we'll have to add another override method. And the one we're looking for is OnModelCreating. OnModelCreating is an override that fires when the application starts up, unlike save changes that fires every time we save something. Within OnModelCreating, this is where we'll use a query filter. Our filter will say only return those rows where the tenant ID equals the current tenant ID from our current tenant service. And with those two things, we have a basic multi-tenant architecture. But if you try to run this right now, you'll get an error. The problem is that in our tenant resolver, which triggers at the beginning of the request, we use this current tenant service, which has the ApplicationDbContext being instantiated in the constructor, and the ApplicationDbContext needs this service to already be ready to go. So that's a problem. Now, if you try to run this right now, this is the error that you'll get. A circular dependency was detected. So what we need to do is we need to create another DB context, one that is just used for looking up the tenants in that middleware. So go to your models folder and let's create a new DB context. Let's call this TenantDbContext. The TenantDbContext should also derive from the DbContext class from Entity Framework Core. And it should only have one DB set, which is tenants. Now, like we said earlier, this is only going to be used for looking up tenants. It won't be used for any kind of migrations. When we add any other kind of entity to our application, like customers or orders or whatever, we won't add them here. We'll add them to our ApplicationDbContext. But since we're using two DB contexts now, we need to give DbContext options another parameter. So just put TenantDbContext here, and in ApplicationDbContext, pass ApplicationDbContext to the options here. Finally, we'll need to register this new database context like so, using the same default connection. Back in our currentTenantService, we'll use this TenantDbContext instead of the ApplicationDbContext, and now we won't have any problems with the circular dependency. So let's go ahead and run the app. So open up Postman and make sure that you've got your localhost port correct to whatever yours is locally, and make sure that you have a key for tenant, and let's give it a value for beta tenant. That's one of the tenants we created manually in SQL Server. And our body will go to raw JSON and format it like so, giving it a name and a description. Click send. And so far it looks successful. Let's go ahead and create a few more products. And change the header for some of these products. Now when we go to get our products, when we put in our beta tenant, we should only retrieve the products that belong to beta. And let's see what happens. Perfect, it looks like it works. So let's change the value to alpha now and send the request. And look at that, multi-tenancy. Now if we want to see how this all works step by step, we can go back here and we can set a few breakpoints. The first breakpoint that'll be hit is our tenant resolver. So let's go ahead and set a breakpoint here. The next step in the request journey is the currentTenantService. So let's set a breakpoint here. And then let's set a breakpoint in the controller, and we'll follow it through at that point. So our header here is set to alpha. Let's go and send. As you can see, the first breakpoint hit is the tenant resolver. And here we can see that the tenant from header value is alpha. So now it's going to go to the tenant service, and it's going to find that this tenant exists. At this point, maybe we retrieve other information about the tenant, who knows? So if our tenant info is populated, then we set that tenant ID here in the service, and now the request is hitting the controller. When we go and add the product with the ApplicationDbContext, we can see that the ApplicationDbContext has instantiated with the alpha tenant ID, and so it's automatically going to save that tenant ID as alpha when it saves this record. Now if we do the same thing for a GET request, we'll see once again that the first thing that gets hit is the tenant resolver middleware, and then we set that information in the currentTenantService. And in the ApplicationDbContext, I'll set a breakpoint here in the constructor because I want to show you that if we set a breakpoint here in OnModelCreating, it'll never be hit. And the reason for that is that this override only fires once on the app startup. So that might be a bit difficult to wrap your head around when you're messing with this, but that's just the way it works. So that concludes the tutorial. I hope that you learned something. Again, there's a written version of this at my blog, aspnano.com. This is similar to how multi-tenancy is implemented in the Nano Boilerplate. The Nano Boilerplate, however, takes this a few steps further. It integrates with ASP identity. It's built around clean architecture. It implements the repository pattern, the generic specification pattern. It has endpoints and controllers for managing tenants, managing users, and the full version comes with 2 UI projects. One is a Razor Pages project and the other is a React project. Both of them are made with premium themes with a full set of components, light and dark mode. If you're an individual or a startup or a small team and you want to build SaaS or a multi-tenant web application, definitely check it out. It'll save you a lot of time. The link's in the description. If you like this video, go ahead and subscribe and I'll post some more. And good luck with your journey.